what we are saying is over here till st minus 2 we are doing, and st minus 1 we are assuming to be sr, and st minus 1 we are assuming to be sr minus 1. So for that, again for this we will again consider for st we have considered over here, right, where that one, yeah, for st we have found that for st minus 1 it can be sr or sr minus 1. Then again we have branched this, because for this one what we have to do is this is I will write again what I am trying to say. If for st it is sr, then for st minus 1 it can be sr minus 1 or sr or sr minus 1 it can be. So again if you are branching this like saying that st minus 1 is sr, this one here, as you can see st minus 1 is sr, till st minus 2 only we will take, because st we have taken it as it is sr itself. St is always fixed as sr. We are now seeing for other terms, and for and we have to plus, because it can be st minus 1 can be sr minus 1 also. Then we have to now see for st minus 2. For st minus 2 it can be sr. If it is sr, then st minus 1 it is sr, means st minus 2 it can be sr or sr minus 1. And here as you can see st minus 1 it is sr minus 1, then st minus 2 it can be sr minus 1 or sr minus 2, sr minus 2 or sr minus 1. And we have to multiply that like whole term, this whole term, like probability of st is equal to sr, because that is fixed. We are started from that only. It is st is equal to sr given the target symbol, actual target symbol sequence or input sequence, ground truth values. We have to consider that, and we have cases like st minus 1 can be sr or sr minus 2. And again in this probability we have cases like st minus 2 can be sr minus 1, and in this we have st minus 2 can be sr minus 2, sr minus 1. If for example here st minus 1 is sr, and for here st minus 1 is sr minus 1. So like that we need to move on. Now in forward algo, as I have shown you, if you are calculating for this st is equal to sr, we need to have alpha t minus 1 r minus 1, this thing is this thing, and alpha t minus 1 r minus 1, t minus 1 r. T minus 1 r is nothing but this thing, and this thing is t minus 1 r minus 1. So t minus 1 r minus 1 is this thing or this thing, and t minus 1 r is this thing or this thing. So it's like this. So alpha tr is equal to t minus 1 r this term, t minus 1 r minus 1 this term, whole multiplied by this thing yt of s of r, probability of occurring of that particular symbol at timestamp t. That's it. Nothing like in given that, nothing like that. That is like different probability equation which we have seen over here, given that these things. Okay, fine. Now it's simple. So find this, we want this cell and this cell and entire that sequence. So an initialization, how this algorithm works, we can see like we have follower algorithm initializing, like we need to do for that. I will just small map I will give you, graph to give you clarity. If we have something over here for all the 0 terms, this is L, this is T, we need to like first one we need to have s of 1. For example, this is Z, X, gamma, Z. S of 1 will be Z itself. So we need to initialize for T comma L, right? So for all 0 timestamps, so we need to initialize like this, and again we will just nullify this for the reasons which we have previously discussed, because it's decreasing downwards, and first symbol will be always the first letter and the last symbol will be always the last letter to match with the ground text or ground truth values. And alpha 0 of r we will keep as 0 for r greater than 1, and for every t, for every timestamp t, alpha t comma 1 will be alpha t minus 1 comma into 1 into y t of this one. So for every 1 like t1 L is equal to 1. So for suppose L is equal to 1 means this thing. So for this it comes from over here itself. So t minus 1 1. Previously in Viterbi also we don't have like this for 0th cell. Here we are taking 1. So that is from 0 for suppose, or it's from 1 means we don't have like this, so we just have this, so we just initialize this over here like this, t minus 1 or 1, this thing. So to get over here we can just get from this summation and into this yt of s of 1, it also yt is nothing but y1 over here. And for L is equal to yeah, we have taken 1 only, I guess, like t is equal to 1 only, this one. So there also 1 only, like in Viterbi also, because this is a t of 0, t is equal to 0, t is equal to 1, so on. Now from L is equal to 2 means L maybe here we have taken 1 and there also 1 or 0, so here it is 1. From 2 means this one we can get from over here or over here, so like this or this to get over here. So that is again we are summation, we are doing the summation, and we are multiplying that with the probability over here, like y for here y1 of x s of 1, and we are running through the loop. That means we have for timestamp this thing, this thing, this thing, we are calculating, and for just 1 we are calculating over here, same as with everything. And we can apply log to overcome like any underflows. If we have, we can just apply log. This can be computed entirely without underflow if you apply logs to the this algorithm, this formula. And other way of writing which can be useful while computing derivatives, we can just divide it to like partial derivative all those, so alpha at and alpha we can just convert it, and again the same procedure we have to apply. As you can see, we will just calculate alpha hat, then alpha hat into yt we will do, so that it like derivative will be easy, because yt is computed at last here in the alpha, and like in middle terms it is not there, so it will be easy. Now this is a forward probability and forward probability game. Now we need to find beta also. So beta we can just find something like this. Beta is nothing but same again, t minus 1 to k, it comes in backward direction, so we are keeping 1 and then t minus 2 to down to 0, so it comes from here to here. For example, if you have something like this, and this is st and this is a backward algorithm, it comes like this, forward algorithm to reach here like this, and this is st is equal to sr. So we are again doing the st plus 1 to k. That means if we are over here and t plus 1 k, this thing, so we reached over here like this, so in backward algorithm it will be like this in this direction. And for all other terms, and this is just for k term, last term, because last term is reached in this direction only, like we have reached like this only, we can't reach like this, or we can't reach like this.